We have improper integral. Our function, let me put this here, f of x is equal x over 2 minus x. Our function f is continuous on the interval from 0 to 2. On the left side we have closed interval. Why we have on the right side open? Because for x equals 2 we will have 2 minus 2, so we will have 0 in denominator. We cannot have 0 in denominator. So for x equals 2 our function is discontinuous. So in this case we need to rewrite our improper integral to limit, and we will put t goes to 2 from the left side, because we have interval from 0 to 2, so we are going to 2 from the left side, and we will have definite integral now from 0 to t. And now we have to just copy our integrand x dx over 2 minus x. So to find this limit, first we will do integral of x dx over 2 minus x. Because in numerator we have x in first power, in denominator we have x in first power. So first, to find this integral, we will do long division. So we have to divide x by 2 minus x, so I can rewrite this, that is negative x plus 2. So x divided by negative x is negative 1. Negative 1 times negative x is x. Negative 1 times 2 is negative 2. Now we have to do subtraction. And we have x minus x is 0. 0 minus and minus give us plus, so will be only 2. So we can rewrite our integral to form negative 1 plus, and we have reminder, 2 over 2 minus x, everything with respect to x. We have integral. So this is equal. We have integral of sum, so this is sum of integrals. Integral of negative 1 is negative x, and we have plus 2 we can take before integral, and we have integral of 1 over 2 minus x dx. To do this integral we can use substitution method. Let me put that 2 minus x is equal u. So we have to find the derivative of both sides with respect to x, so we have negative 1 is equal du to dx. Now we will multiply both sides by dx, so we have negative dx is equal du. We have only here dx, so now I will multiply both sides by negative sign, so we have that dx is equal negative du. So now we can rewrite negative x, we will copy, and we have plus 2, and we have integral of dx, we will substitute by negative du. So let me put first 1 over 2 minus x is u, and we have negative du. So this is equal. We have negative x. Positive and negative give me negative, will be 2, and integral of 1 over u is natural logarithm of absolute value of u. So now we can come back to our substitution. U is equal to minus x, so this is equal negative x minus 2 natural logarithm of absolute value of 2 minus x. So now we can solve our limit. So let me put this here. We have limit t goes to 2 from left side, and we have definite integral from 0 to t, and we found that integral of x over 2 minus x with respect to x is equal this. So we will write this first. We have x over 2 minus x dx. This is equal limit as t goes to 2 from left, and instead this integral we will put negative x minus 2 natural logarithm of absolute value of 2 minus x, and because we have definite integral we have to put the limits. We have from 0 to t. Now first we have to put the upper limit and we have to subtract the lower limit. And of course limit we have to copy as t goes to 2 from left, and in brackets we will replace x's by t first, so will be negative t minus 2 times natural logarithm of absolute value of 2 minus t, and we have to subtract the lower limit, so we have to put 0. We will have negative and negative give me positive, and we don't have to put 0, so we will have only positive 2 natural logarithm of absolute value. 2 minus 0 is 2. So this is equal. We have limit as t goes to 2 from left, and in brackets we will have t goes to 2 from the left side. To first expression we can replace t by 2, so we will have negative 2. Let me put this constant first, so will be plus 2 natural logarithm of absolute value of 2 is 2, natural logarithm of 2, and we have minus 2 natural logarithm of absolute value will be t goes to 2 from the left side. So we will have 2 minus almost 2. So it's almost 0. We know that natural logarithm, the graph of natural logarithm, path 1 is something like this. When we are close to 0, our graph going to negative infinity. We have 2 minus almost 2, so will be almost 0. Let me write this here, 0. So when we are going to 0, our logarithm is going to 0, we are going to negative infinity. So this whole expression, natural logarithm, going to negative infinity. So when we multiply negative 2 times negative infinity, it will be positive infinity. And if we add positive number or subtract, we will still have infinity. So we can write that our limit is positive infinity. So we got that our limit is positive infinity. It means that our original integral is divergent. Let me write this. This is my solution.